Hey everybody, this is Longo, and in this video we are going to do some more proving of trig identities. But these are going to be a little bit different. Some different steps that you might encounter in some of the more challenging trig identity proofs. Not that it's hard, it's just that it's a little bit different than some of the examples that we've already seen. So I figured we'd, give it a try. Do something a little bit different. So this first example. Right off the bat, you see a cotangent squared x on the top, which is a Pythagorean identity. So we're going to quickly change that to cosecant squared x minus 1 over 1 plus cosecant x. And then, of course, that's going to be equal to 1 minus sine x over sine x. One of the things that you can do is factor. So cosecant squared x minus 1 is actually difference of two squares. If you were to just think back in the day to x squared minus 1, you would multiply, or you would turn that into x plus 1, x minus 1, because it's the difference of two squares. Well, that is what we are going to work with here. So if we were to factor cosecant squared x, that would give us cosecant x plus 1 and cosecant x minus 1. And that is all over 1 plus cosecant x, which you can see is just the same as cosecant x plus 1. So now those guys just cancel. So now you are just left with cosecant x minus 1. And we need a denominator somewhere, because we are trying to get this equal to 1 minus sine x over sine x. Well, if you look at cosecant x, we know that that is 1 over sine x minus, and the only way you can subtract or add fractions is if they have a common denominator. So we're just going to change 1 to sine x over sine x. And now you have a common denominator, so you're done, pretty much. You're just left with 1 minus sine x over sine x. Okay? Simple as that. So again, it's a little bit different, a little bit trickier than some of the other examples that we've done, which is the purpose of this video, is to get you thinking in other ways, such as factoring. In this next example, we are going to do what is known as multiplying by a clever form of 1. So when you look at this example, there's different approaches you can take to this, but one of the things you can do is multiply by a clever form of 1. And what I mean by that is down here we have a secant x minus tangent x. Well, what I'm going to do is I'm going to multiply both the top and bottom by secant x plus tangent x. So again, it's multiplying by a clever form of 1. And what happens when you do that, if you distribute this, you're going to have secant squared x plus secant x tangent x. And if you look at that, that's what we're trying to find. However, we have a denominator, and your denominator is, once you FOIL this, you're going to have secant squared x minus tangent squared x. Okay? So the whole point of doing that is so you can come up with this Pythagorean identity. Now, of course, that's still equal to secant squared x plus secant tangent x. And again, secant squared x minus tangent squared x is a Pythagorean identity, and that gives you 1. So now that's gone. Your denominator is over with. So you are just already finished. The reason why I wanted to do that one is just so you can see the step of multiplying by a creative form of 1 Because remember, if you multiply 1 to anything, it's going to stay the same. And by multiplying the top and bottom by secant x plus tangent x, you didn't change anything, you didn't do any bad math or anything like that. You're just good to go. And this last one is actually a very easy question. To be honest with you, you can just change this right side to 1 over cosecant minus 1 over secant and start doing adding of fractions and getting a common denominator. But I wanted to do this one in a different way for you to show you something called splitting a fraction. Okay? Now, think about how you add and subtract fractions is you have to have a common denominator. So we know that 1 over 3 plus 2 over 3 is equal to 3 over 3. Because the denominator doesn't change. So if we were to say x over 3 plus 2 over 3, that is x plus 2 over 3. So if we wanted, we can say that x plus 2 over 3 can just split into this. So if we're going to split a fraction, we can just split this to secant x and then minus cosecant x and give each one of them secant x, cosecant x. Give them the common denominator it came from. So again, the only reason I'm showing you this is so you have just one more tool in your toolbox to do proofs. And then by doing that, you can see these secants cancel and these cosecants cancel, which is going to take you to 1 over cosecant x here minus 1 over secant x on that side. And the last step is really simple now. Now you're just going to do the reciprocals, and you now have sine x minus cosine x is equal to sine x minus cosine x. One thing to be very careful of, you can do that, but if you had 3 over x plus 2, don't you dare say that can be 3 over x plus 3 over 2. You can never split a denominator. Remember, you need to have a common denominator before you add. You can't say, then otherwise, what is this going to give you? This is going to get a common denominator of 2, and this is going to give you an x. And now you're going to have a 6 plus 3x over x plus 2, or 2 times, yep, doesn't work. You can't even do that. So just be careful. You can split a numerator. You can never split a denominator like that. Okay? Anyway, this is your third part of extra practice with trig identities. Hopefully you found this helpful. This is Longo and I'm out. See you, bye.